Hello everybody, welcome to the session on apcalculus. So let's get started. The first question is on limits. Evaluate limit as x tending to infinity 20x squared minus 13x plus 5 by 5 minus 4x cubed. Now whenever we have limit as x tending to infinity, we will divide by the highest power of x in the numerator and denominator. That is x cubed here. So this becomes, what will this be when you divide numerator by x cubed? It is 20 by x minus 13 by x squared plus 5 by x cubed. Denominator is 5 by x cubed minus 4, and as x tends to infinity, 1 by x tends to 0. So the answer will be 0. Coming to the next question, evaluate, this is a question on limits again. Evaluate limit as h tending to 0, log 2 plus h minus log 2 by h. We make use of the fact that f dash a is limit as h tending to 0, f of a plus h minus fa by h, and fx is log x here. So limit as h tending to 0, log 2 plus h minus log 2 by h becomes f dash 2. That is, f dash x is 1 by x, so f dash 2 is 1 by 2. The third question, look at this table here, you are given x, f, f dash, g and g dash. Find the average rate of change of f on the closed interval 1 to 4. The average rate of change on the closed interval 1 to 4 is given by f4 minus f1 by 4 minus 1. f4 is 6, f1 is 2. So 6 minus 2 by 4 minus 1, which is 4 by 3. The next question is, if hx equal to g of fx, find h dash 3. So we are using chain rule. So using chain rule, h dash x becomes g dash fx into f dash x. That is g dash f of 3 into f dash 3. Now f of 3 is 4 and f dash 3 is 2. So it becomes g dash 4 into 2. G dash 4 is half. So half into 2, which is 1. Coming to the next question, if y equal to e raised to minus x squared, find y double dash 0. Y dash will be e raised to minus x squared into derivative of minus x squared is minus 2x. Y double dash will be e raised to minus x squared into minus 2x into again derivative of minus x squared, which is minus 2x. So you get minus 2x the whole squared plus e raised to minus x squared. Derivative of minus 2x is minus 2. And now put x as 0. So y double dash 0, this term becomes 0. It becomes minus 2. The next question is, the derivative of a function f is given by f dash x equal to x squared into x plus 1 the whole cubed into x minus 4 the whole squared. Find the set of values of x for which f is a relative minima. So f dash x equal to 0 at x equal to 0, minus 1 and 4. So for f to be a relative minimum at a, it has to change from negative to positive in a neighborhood of a. So it will go like this. And that will happen only for minus 1 because it's an odd power. So f has a relative minima at x equal to minus 1. Now we go to the next question, that is continuity at a point. If fx equal to 3 e raised to x minus 1 minus 2 when x less than or equal to 1 equal to 4x squared plus bx minus 5 for x greater than 1, what is the value of b for f to be continuous at x equal to 1? So, if you take the left hand limit, it is limit as x tending to 1 to the left of fx. That is limit as x tending to 1 of 3 e raised to x minus 1 minus 2. If I put x equal to 1, you get e raised to 0 is 1, 3 minus 2 is 1. And limit as x tending to 1 to the right of fx becomes limit as x tending to 1, 4x squared plus bx minus 5. When I substitute, I get 4 plus b minus 5, which is b minus 1. Since it's continuous, the left hand limit equal to right hand limit. So b minus 1 equal to 1 or b equal to 2. The next question is on velocity and acceleration. So you are given this graph. The graph shows the velocity of an object moving along a line where t lies between 0 and 9. At what time does the object attain its maximum acceleration? Now acceleration is slope of velocity, and you can say that from the graph the slope is largest when t lies between 8 and 9 because it is a slope from 4 to minus 4 to 0. So the velocity is maximum acceleration is between t to 9. The next question is find the point at which the object is farthest from the starting point. Distance is maximum when velocity is increasing, and velocity is maximum at t equal to 6, you can see here, because here it is negative distance. So the object is farthest from the starting position at t equal to 6. Now at t equal to 8, the object was at position x equal to 10. At t equal to 5, find the object's position. So we first find the displacement from t equal to 5 to t equal to 8. So that will be area of the graph from 5 to 6, that is half 1 into 2, and 6 to 8 it will be half 2 into 4. Here it is negative because it's going down. So it will be half 1 into 2 minus half 2 into 4, which is minus 3. And let k be the object's position at t equal to 5. So k minus 3 is 10 because minus 3 is the displacement from t equal to 5 to 8. So we get k equal to 13 when you simplify. So that ends questions 1 to 7 of AP Calculus. Please do subscribe.